Hey, hi everyone. Yeah, I know everyone is tired of the long day of talks, but yeah, the topic I'm going to talk about is really interesting. I'm going to be talking about the enhanced gas UIs in MetaMask. A bit about me, I'm Jyoti. I'm based out of New Delhi, and I'm a senior developer with MetaMask extension team. And I have been part of the project to improve our gas UIs. Now, gas on networks is one of the most interesting and complicated topic. And they're important. They're important because they're a cost for our users. And they are complicated because gases are highly unpredictable. They are volatile. There are spikes and slows. And as a wallet, it's a challenge for us to represent gas in a way which is least confusing for the users. So we need to ensure that our users' transactions are not stuck waiting for a block. Like they have sufficient gas to find place on a block, and at the same time, we need to ensure that our users are not overpaying for gas. Now, during the course of this transaction, in next 20 minutes, I'll take you through what is Ethereum gas, as it might be a new topic for some of you. We'll see how gas pricing in Ethereum was done traditionally. Then we'll look at EIP 1559 and how that changed the gas pricing mechanism in Ethereum, and what MetaMask has done to adopt EIP 1559. Then we'll see what were our learnings from our initial implementation of EIP 1559 and how we have improvised upon that. Now, to begin with, what is gas and Ethereum? So gas in Ethereum is a kind of like analogy for fuel for your car. So you need fuel to run your car, and in the same way, you need gas in Ethereum network to run your transaction. So gas is a way of allocating expensive resources over the network. To run your transaction, you need these resources on Ethereum. So as you can see in the diagram over here, so every small network resource or any computational resource on Ethereum has a cost. That cost is calculated in terms of gas. So gas is a way of resource allocation in Ethereum. And since its implementation in Ethereum, a lot of other projects have started using gas as a mechanism of resource allocation. During the course of presentation, I'm going to be using the term gas fee and transaction fee sort of interchangeably. So yeah, don't get confused with that. Also, one important point, yeah, a couple of people also came over to the booth to us, and they were asking, like, when is MetaMask releasing zero gas transaction? So MetaMask is not who charges this gas. So MetaMask is just a wallet. We take your gas inputs, we send it over to the network. So it's a network that gives you these computational resources, and it's the network that is charging this gas for your transaction. So MetaMask, at least for one-on-one transactions, MetaMask is not charging anything. Yeah. So how would you calculate the total amount of gas your transaction is going to need? So it's similar, it's like, and again, an analogy to the fuel situation. So the unit of gas your transaction need multiplied by price per unit of gas. So consider like how much money you're going to spend to refuel your vehicle. So that will be the number of liters of fuel that you will take multiplied by the price of the fuel. So the number of unit of gas your transaction will need depend on the complexity of the contract and the size of the contract. That multiplied by gas price will give you your total spending on gas for your transaction. Now the unit of gas the transaction will need is going to be constant. So the magic lies with the gas pricing. In Ethereum, gas pricing traditionally was done using an auction-based mechanism. So users in their transaction will specify their gas fee bid, or what they used to call as gas price. The miners will choose the transaction with the highest gas price, and they'll mine it. Now, this looks very simplified. Your total expenditure on gas will be the units of gas, which we usually specify as gas limit on the UI, multiplied by gas price. And traditionally, the block size was fixed to 15 million gas. Now, this mechanism is very simplified. There's one variable, which is gas price. The miner will choose the transaction with the highest gas price. All of the gas fee will go to the miner. So simple as that. But the mechanism has drawback. in this mechanism, the gas pricing is totally controlled by the miner. So the network has no control over gas pricing. And the second drawback is that the bots competing for gas on the network can result in gas prices really surging. And there are spikes, sharp spikes, and everyone else on the network at that point has to suffer and pay more for the gas. So users were not happy with this auction mechanism. They were complaining. With the nature of auction, it was highly unpredictable. It was hard for a user to know what will be the gas price in the next block and what they need to pay to be on the next block. Ethereum overhauled their gas mechanism with EIP 1559 in London upgrade last year. It was in August 2021. In EIP 1559, this auction mechanism and gas price was replaced by these two variables, which are called as base fee and priority fee. And the block size was also made variable. It was 2 times of what it was previously. So previously it was 15 million gas, and now it's 30 million gas. Now I'll tell you what is base fee and priority fee. So, yeah. I hope everyone is with me so far. It's making sense. Okay. So base fee is the minimum price per unit of gas you need to pay for your transaction to be included on a block. Base fee is decided by the network. So it's not the miner deciding it. It's the network who decides the base fee. For Ethereum, it's always in ETH, and the base fee part is burnt out. So there are very important, significant consequences of these. Like the network finally has a control over gas pricing. And this also makes ETH a deflationary asset. And a big advantage is base fee is highly predictable. Since it's the network who decides the base fee, and there is a clear, so if the block is like more than 50% occupied, the network will increase the base fee by 12.5%. If the block is less than 50% occupied, the network will decrease the base fee by 12.5%. So that way, base fee is highly predictable. So if you see, like, here you can see, like, when the block size was more than 50%, the network, in the next block, so the gas fee for a block will depend on the block previous to it. So if the previous block was more than 50% occupied, the network will increase. And so an increase cannot just go on infinitely. So at some point, the base fee increase will stop, it will start decreasing, and it will eventually reach an equilibrium. Now, the second variable in 1559 is priority fee. Priority fee, or what we call as miner tip, is a way to incentivize the miner. And priority fee is your tool if you are looking forward to participate in the gas war. So if you are running a time-critical transaction, you are participating in an NFT drop or minting, or the market is highly volatile, and you need to ensure that your transaction is executed really fast, add a high priority fee to it. So miner will be happy to run your transaction. So now, gas fee, in a way, priority fee is a bit similar to gas price pre-1559, but 1559 has introduced one more variable, which is base fee, and it has improvised the overall gas pricing mechanism. So now gas pricing for your transaction will be unit of gas, again represented as gas limit on the UI, into base fee plus priority fee. So if you look at the scenario like pre-1559 with auction-based mechanism, there was fee which was going completely to the miner. Now in EIP 1559, we have base fee, which is burnt out, and we have miner's tip, which goes to the miner. Since EIP 1559 was introduced in August last year, MetaMask was amongst the very first browsers to add support for it. So if you are creating a type 2 transaction, which is a transaction that supports 1559, on a network which is supporting 1559, you'll see this transaction confirmation screen in MetaMask, wherein you can see the max fee specified, and you can confirm your transaction. It will use the default gas estimate suggested by MetaMask. Or if you are an advanced user, you can click on the edit link. It will open the advanced gas fee model, where you can select one of our predefined estimate, low, medium, and high. Or if you are an even more advanced user, you can provide your custom estimates for max fee, priority fee, and gas limit. So by default, MetaMask will suggest you the medium estimates. Now, there are a couple of terminology here, which is always confusing. So I'll take a minute to explain that. So what is gas limit? Gas limit is the maximum amount of gas I authorize for consumption for my transaction. So suppose I specify the gas limit as 5,000. Now my transaction needs only 3,000. So the network will use only 3,000. It will not use 5,000. But suppose I specify the gas fee as 1,000, but my transaction needed 3,000. So it will run out of gas. Whatever gas is consumed will be lost, and my transaction will not be executed. So always specify a gas limit, like a bit more than what you think your transaction is going to need. Second, base fee. Base fee, as we saw already, is the minimum price per unit of gas, which is specified by the network, and it's ultimately burnt out. Priority fee is in theory optional, but yeah, practically priority fee of 2 GUI is almost always needed to run your transaction. Priority fee is, again, price per unit of gas. It is paid to the miner. It is decided by the user. Then we have this field called max fee per gas, which is a very confusing value. So max fee per gas is priority fee plus maximum amount which you are willing to pay for base fee. So the thing is, base fee can be changing. So I'm creating my transaction, and the base fee on the network might be, say, 50 GUI. But by the time that my transaction is executed, the base fee on the network might have got up to 75 GUI. So if I specify just a base fee of 50 GUI, and I send my transaction, when it's executing, the base fee has got up to 75 GUI. What will happen is my transaction will be stuck. It will be waiting for base fee to come down to 50 GUI, and then it will be executed. So what I can do is I can specify max fee per gas, which you specify in MetaMask. So that is maximum what I'm willing to pay. So I can, in my transaction, I can specify max fee per gas as 100 and priority fee as, say, 10. So what it will do is 10 GUI will go in priority fee, and rest of 90 GUI is what I'm authorizing the network to use for my transaction. So actually, the network might use only 50 GUI. It might use 75 GUI, and the rest will be refunded back to me. But if it's less than that, my transaction will wait for the gas on the network to come down. So yeah, just to give you an example. So suppose in my transaction, I specify max fee per gas as 100. My spending on priority fee is 20, and base fee is 80. So in all, 20 plus 80 is 100, and my transaction has sufficient gas. The transaction will be successful. Now, suppose I specify max fee per gas as 120. Then the priority fee part is 20. The base fee when my transaction is executed on the network is 80. So in all, I need 100 GUI. So 20 GUI will be, so the transaction will go successful, and 20 GUI will be refunded back to me. Now, suppose I specify max fee per gas as 80. Now, priority fee is 20. Base fee at the time of transaction execution is 80. So in all, I need 100 GUI of gas, but I specified only 80, so my transaction will be stuck. It will be waiting for gas fee on the network to come down to 60, and then only the transaction can be executed. So yeah, I hope this max fee per gas is clear. Yeah, it's confusing. Now, ever since we introduced EIP 1559, we have been collecting data on the network. We have been looking at gas behaviors on the network after 1559. We have been collecting user feedbacks, and we had some very interesting observations. So it is expected that with EIP 1559, the gas spikes will go down, but we found that the spikes were still there. User psychology on the network has a huge influence on gas pricing, and there are actually multiple factors, but they're highly unpredictable. And we found the gas spikes were there, and typically our users were falling into 3 categories. So there's a category of sit and wait users. They don't want to pay high for gas. They're happy to skip the spikes, but their transactions are not time critical. They're happy to wait and don't overpay. Then there's a second category of users for whom gas is not a concern. Like, they're happy to pay whatever it takes, but their transactions are time critical, and they want it to be executed really fast. And then there's a third category of normal user. They will just go with what is the market trend at the point. So we have worked towards reducing the complexity of our gas UIs. We designed and technically implemented controls to reduce user confusion. In MetaMask, we call it EIP 1559 V2. Here's a little video.
We've updated the gas UI in MetaMask to make it more accurate and easier to use. If you're interested in trying out the new feature, you can turn it on in Settings, Experimental. The new UI does a few things. First, we've changed the priority selections to low, market, and aggressive to reflect improved market-based gas fee estimations, especially in response to volatile conditions. Next, you can now set Advanced as your default option, and your customized values will be saved and used next time. Finally, we've simplified the customization of fees, which means no more advanced mathematics required to calculate the max base fee. Try out the new UI now on Extension and
Yeah, so as you all just saw, we have introduced new 3 friendlier level of estimates, which are called as low, market, and aggressive. So our new low, they are really low. So if you want to skip the spike, you're happy to wait for gas price to come down on the network, go with our low estimate. If you want to go with the current market trends, go with our market estimate. And if you're running a time-critical transaction, you want to win the gas war, your transaction is critical, go with the aggressive estimate. It will set your max fee and priority fee to really high, and it will ensure your chances of winning the gas war is high with that estimate. So if you create a transaction now in MetaMask, on the transaction confirmation screen, you'll see that market estimate by default. So whatever is the current gas field level in the market, it will show you that by default. Here you can click this market link, and it will open the added gas fee model, where you can select one of our predefined values of low, market, and aggressive. And you can select either of these. Now, MetaMask has done a lot of very good job in deriving these estimates. We look back on the blockchain, we look on the gas trends on the blockchain, we collect data from recent blocks on the blockchain, and we run our algorithms over that data to derive these estimates. Being one of the highest used wallets, it's very important that we come up with the right estimates, because if we are estimating on to the lower side, that will mean a lot of transactions on the network will be stuck waiting for gas prices to come down. And if we are estimating on an upper side, that will mean the gas pricing on the network as a whole will increase. So yeah, being the highest used wallet, it's our responsibility to ensure that our estimates are good, and we have done a good job at them. Like, a lot of projects use our estimates as benchmark. Also, on this added gas fee model, at the bottom, we show you the current network status, so you can make a more informed decision at selecting the predefined estimates. You can see the current value of base fee, priority fee on the model, and how is the network currently behaving, so whether it's stable, or it's slow, or it's high, so you can accordingly decide the gas fee estimate that will be appropriate for you. Also, on our gas UI, we have added informative tooltips. They'll show you the breakdown of gas price that you're paying, and they'll give you more context of what a value is, and they're especially useful for new users. We have also changed the advanced gas controls, which allow you to set custom values for gas. So the new controls not only allow users to set custom value for gas, but they also allow you to save these values as default for you. So, you can save these values default. So if you're running a time-critical transaction, you want to execute it really fast, you can save these custom values as default. Come create a transaction. It's going to use these defaults, your default gas settings, and you can quickly confirm. Or if you want to add it these custom values, that will be a single click. So if you have these defaults set and you create a transaction, this is what you're going to see in confirm transaction page. It will use these advanced settings for you. You can click that advanced link and select one of the predefined gas estimates, low, medium, and low, market, and aggressive, or you can click the edit link. The edit link will take you to the advanced gas fee model where we allow you to enter custom value for gas. So you can set a custom value for max fee, which is like the maximum amount you're willing to pay for the transaction. You can specify custom value of priority fee, which you're happy to pay to the miner, and your gas limit. Also, in this model, we show you the current network values. So we show what is currently the base fee and priority fee over the network, what has been the range in last 12 hours, so you can make a more informed decision. Also, here we allow you to set these values as default for yourself. So whenever you create a transaction in MetaMask, it will straight away use these defaults. Yeah. The new gas UI has been released last month as of version 10.10.0. It's still in beta, so you can go to settings, experimental, and enable it and use it. The advanced gas UI on mobile side is still under development. Since we've released EIP 1559 v2, we continue to collect user data. We continue to see the gas trends over network. And we continue our work on improvising the gas UI. With the beacon chain merger, we expect more changes in the way gas works on network. Not in terms of like the mechanism, it's going to be EIP 1559, but the user psychology is going to change. The network trends are going to change. And for us, improving the gas UI is a continuous effort. So we've already started thinking of EIP 1559 v3, which will improvise these UIs further. Yeah, so during the course of the transaction, we looked at what is gas pricing and what has changed with 1559. And we also saw how MetaMask has adopted 1559, what we learned from it, and what changes we have done to our gas UI. We look forward to ensure that we provide great user experience and accurate estimates to our users. Now we have time for any questions.